11.2 kilometers per second or 7 miles per second, fast enough to go from Sydney to LA in less than 18 minutes. It's also how fast you need to go to escape Earth's gravitational pull and never come back down. Have we gone faster? Of course we have. We've sent rockets into space, but how much faster? Stay tuned. Today we're going to be looking at some of the fastest objects ever. And to start with, you might think of guns. They shoot things pretty quickly, so what about a really big gun like a cannon? Well, it might be a bit hard to pull out what a typical cannon fires at because, we're spanning several hundred years of military and naval history, but that doesn't mean we can't pull out a few key examples and use those to get an idea. And so to start with, let's look at an old-timey gun, in particular the Vassar cannon, or at least the recreation that was used here. I mean, look at how cool that is. It does look pretty awesome. And not only that, but it was really amazing because they studied these things properly and looked at the muzzle velocity, or at least how fast objects were going when they left the barrel, amongst other things such as their impact against, well, recreated ship sides and other really cool items. However, this study showed that the cannonballs were going a bit slower than they expected, and most of them were subsonic, or below the speed of sound, so we have to move on to something else. Then I hear you asking, what about a bigger gun? So let's look at the biggest gun ever made, which is the World War II Gustav gun and its sister Dora. They weighed 1,300 tons, and with its 32.5 meter long barrel could lob a shell weighing 5 tons, some 30 odd kilometers. I mean, it's basically the textbook example of wasted overkill, but it's also too slow for our purposes. It's big, but the muzzle velocity is only about 800 meters per second, which barely makes it onto our chart compared to escape velocity. However, it's not the fastest firing gun, so let's have a look at what do come in at even better. The V3, which is surprisingly not a rocket, is another crazy German gun from World War II. Built onto the side of a mountain, this 130 meter long barrel and its angled charges could lob shells with a surprising muzzle velocity of 1.5 kilometers per second, which at least puts it a little more squarely onto our chart. And for a modern example that can go even faster, railguns are capable of lobbing shells at about 2.4 kilometers per second. Does this mean that no solid object has ever competed with a rocket? No, there's an exception, and what's more, it's a manhole cover. How did a manhole cover reach escape velocity? Using a nuke, because the answer is always nukes or lasers, or nuke-powered lasers. During the 1950s, people started to realize that testing nukes all over the place was starting to release a lot of unwanted radiation, and that's apparently not a good thing. Who would have guessed? And so it was decided that to help minimize the fallout, a lot of these tests would be moved underground. For one of the earlier tests, they put a nuke down a shaft and then sealed it with an iron cap. When the nuke went off, not surprisingly, the iron cap was jettisoned skywards. Now, they even had a high-speed camera set up to measure the velocity of the iron cap, but it was moving so fast it only ever appeared in a single frame. But it was still possible to estimate how fast it ended up going, which would give it a speed of about 200,000 kilometers an hour, or 56 kilometers per second. Which, if true, and it also just didn't get vaporized by the blast because the amount of energy when a nuke goes off could do that, this would make it the third fastest object in human history. It's a manhole cover, blown up by a nuke. Who would have guessed? However, since shooting things into space using nukes is generally not a very good idea, let's have a look at some rockets. Specifically, let's look at the Saturn V and the Falcon Heavy, because, well, I did promise you a proper drag race. Welcome to today's race. On the left, we have the largest rocket ever launched, the Saturn V. And on the right, here to challenge it today, we have the Falcon Heavy with its 27 Merlin engines. This is shaping up to be quite the challenge for the historical giant. And without any further ado, let us begin today's race. And at liftoff, they're neck and neck with the first major event being the ignition of Stage 2, which occurs roughly at 2.5 minutes in for both rockets. However, from here, the Falcon Heavy does take off pretty quickly. It does launch its payload at about 117 kilometers up, and then quickly pulls ahead of the Saturn V. It will eventually reach about 179 kilometers up before the video footage I was using to get these speeds cuts out, a full minute ahead of the Saturn V for reference. However, the Saturn V will continue to rocket skywards, eventually reaching an altitude of 191 kilometers where it begins an orbit at 7.8 kilometers per second. Still pretty quick. It will eventually increase its orbital height up to over 300 kilometers with an orbital velocity of 10.4 kilometers per second. It is from here that, if it's necessary, the Saturn V can launch things, since it's the only rocket to ever do so, beyond Earth's orbit. Obviously, for example, that is the moon in quite a number of cases. This is still the world's most powerful rocket, and yes, it was second place today, but that's only because it is heavier and can still deliver a larger payload than the Falcon Heavy. Now, you might ask, what fills the top 2 positions? Well, since we are now in space thanks to our rockets, I can answer that question. And at number 2, the Helios 2 satellite, which clocked a massive and whopping 250,000 kilometers an hour or 70 kilometers per second. At the time, it was also the closest an object has ever got to the sun, at least a man-made object. Now, the high velocity also arises from this fact because to orbit so close to such a massive object, you need to be moving that fast. And also brings up another interesting point that one of the most energy efficient methods in the universe for converting potential energy into kinetic is to drop it into a gravitational well, or basically let the object fall. Which does mean theoretically, yes, you could heat your room very efficiently using a miniature black hole. Maybe I should make a video on the practicalities of such a thing, or lack thereof. And now for the fastest object man has ever made. Drumroll please. The Parker Solar Probe at a whopping 724,000 kilometers per hour or 201 kilometers per second. This thing is fast enough, according to NASA, to go from Washington DC to Philadelphia in 1 second. Now, how did we get so much faster than the already orbiting the Sun Helios 2? Easily. We just orbited the Sun closer. 7 times closer to be precise. No, that's not cheating, because we didn't paint it red. The probe's mission was to study solar winds and how heat and energy are dynamically distributed throughout the solar system. And while scientists have wanted to deepen their understanding in this area for quite some time, it wasn't until recently that we actually had the technology to shield a probe against the 1300-degree solar corona that it had to fly through to get these measurements. The probe's findings will help us here on Earth by giving us a better understanding of solar emissions and their effects on the weather, space weather, disturbances to our magnetic field, and radiation throughout the solar system. All of which can affect everything from satellites and your internet to interstellar travel. So, even though we set a massively cool record to get here, it was also incredibly useful to do so. So then, I hear you asking the next question. What about theoretical modes of interstellar transport and their associated velocities? Well, although that would make for an even more epic list, it's such a broad topic that it probably deserves its own video. So comment below the sort of things you want to see there, if at all you want to see it. and I'll try and get around to it. However, I'll still take a moment today to talk about two theoretical modes of interstellar transport. The first being the Super Orion, an Empire State Building sized mega rocket powered by more than 1,000 nuclear fusion bombs. This thing sounds absolutely insane, but what's more, it's technically possible with currently existing science. Freeman Dyson also calculated that such a rocket could get us from Earth to Alpha Centauri in less than 100 years, which is actually somewhat impressive, even if a bit impractical. Also, the second method that I want to talk about is the solar sail, which is basically where you utilize light to push an object really, really fast. Yes, you can push things with light. The solar sail is theoretically proposed to be able to reach velocities of 30,000 kilometers per second, 10% the speed of light, or technically known as 0.1 c, which is just insane for a non-warp drive method of transport. And yes, warp drives are also possible. Both of these go to show that the answer is always nukes or lasers. Remember, I'm almost a doctor, and until next time, be like a proton. Stay positive. Escape Earth's velocity. Space weather disturbances to our magnetic.